Now that we're talking about brute force, I would like to show you the complete result of doing one element to 5 elements using brute force. So here it is. Suppose I got 10 numbers that I could choose from, and I'm choosing only one. Of course, there are 10 ways of doing it. So, chose one, chose two, chose three. So this is how you read it. If there's a box, that means I chose the number that is above it. So I chose 3. And you see, along this row, I have only one box. That means I chose only one because I'm supposed to pick only one here. So not surprisingly, there are 10 ways to pick a number out of 10. Duh. Let's get slightly more advanced. What if you're picking 2 numbers out of 10? Of course, you could pick these 2. This is what I demonstrated to you, what I demonstrated a little bit earlier. So if you have just keep this guy along here, then you can move this guy along. So you could pick, this would be 1 and 7, right? Just you got to look above there. And this would be 1 and 8, 1 and 9, 1 and 10. And when you exhaust this 1 and something stuff, then you go to 2 and 2 and 4. I cannot use the adjacent number, so I chose next. And da-da-da-da-da, it keeps on going. When you run out, then you go to 3, then you go to 4, then you go to 5, go to 6, go to 7, go to 8. Then there's no more place you can go because then it will be next to each other again, right? You cannot be like that. So when you are choosing 2 numbers out of 10, without any consecutive numbers, you get 36 choices. What if you're choosing 3 out of 10? Then you get, 3. You pack it as much as possible onto one side and let one wander free, goes away, and it gives you 6 choices, right? Well, you ran out of things to do, so you just move this guy 1 over and this guy 1 over compared to this configuration here. You just moved it a bit and then let the last guy go wander away because you could, have more gap in between. You just cannot touch each other. There we go. And when you run out of things to do, then move this guy 1 more and then go. Move this guy more and go. Move this guy more. And at the end, they are stuck at the end. Okay, not much we can do with these 2 guys. So now it's time to move the first guy. Move it to the second column. And then start the show again. It's identical show that you did here. It unfolds here, you see. Except it doesn't have as many spaces to move, so it ends sooner. And every step of the way, it ends sooner. You see how much longer these guys were? And then the first guy has to make a move, and he comes here. Then the show starts over. And again and again. And in the end, everybody's crunched toward the right, and there's no place to move. But before you know it, there were 56 ways of doing this. Whoa, can you do that? With 15 elements? This was 10 elements. That would take a lot of time to do this, right? I took some time to make this for you. So this clearly is not the smart way of doing things, but I just want you to get the feel for what it takes, what they're asking for. This time, if we had picked 4, actually it got easier because it runs out, it's out of space already. So it runs out quicker, and then if you move it, it runs out even quicker. But then again, you got more bars to move, but they don't have much room to maneuver. So this is not different from what we did. And you can just pause this and examine it and make sure that I didn't miss anything. And there are 35 ways of doing this when you have 4 elements out of 10. Notice nobody's touching each other, right? Okay. What if I wanted the 5 elements? It gets truly crowded. Cannot move much, so you just got to move a little bit. And then this is the pattern you get. And still, before you know it, you got 6 different ways of putting these 5 numbers into, choosing 5 numbers out of 10 in such way that no 2 numbers are next to each other. By the way, if I want to choose 6, it's not possible. It will touch each other no matter what.